everyone, welcome to my channel, Tutorlini Test Prep. Today we'll be going over Ottocento number 7, Special Right Triangles. The goal of the Ottocento course is to teach students everything they need to know about the digital SAT Math exam. Please see the link in the description to download this video's worksheet for free. Let's get started. Okay, so the first thing we need to know are these drawings on the reference sheet and some vocabulary. So first, we have what's known as a 30, 60, 90 triangle. You will see that on the reference sheet like this. And we also have a 45, 45, 90 triangle, which you will often see on most standardized tests referred to as an isosceles right triangle, which looks like this. Again, you don't need to memorize these. They're on the reference sheet. And X and S are just arbitrary numbers that represent the ratio of the sides. So, for example, on the left one, if X were 3, you would have sides of 3, 3 root 3, and 2 times 3, which is 6. So, these triangles are always have sides in these ratios. So, just some general advice before we start. You don't need to memorize these. They are on the reference sheet. The reference sheet is located in the top right corner of the Blue Book app. It's just a little button that you have to click on. And you should copy down the figure from the problem and the special right triangle from the reference sheet side by side onto your scratch paper. Okay, so for this problem, very first thing I notice is that the two acute angles should add up to 90. So I'm going to do 90 minus 30, which gives me 60. And now I recognize this is a special right triangle, so I'm going to copy down from the reference sheet the 30, 60, 90 special right triangle. And now I'm going to very carefully identify which sides are which. So these sides are both across from 60, these sides are both across from 30, and these sides are both across from 90, or in other words, the hypotenuse. So we're now going to put that information on the picture, kind of on the outside. So watch what I do. So I'm going to put x root 3, and 2x on my picture in the problem. And now I'm going to put a box around whatever side I have. So in this case, the 4 and the x. And I'm going to write down off to the side x equals 4. I don't need to do anything to solve that. It's already solved. Now I can go in and put x is 4 in for the other side. So x root 3 becomes 2x becomes 2 times 4, which is 8. And x root 3 becomes 4 times root 3. So the length of side AC would be 8 for this one. Okay, so for this guy, I see I have a 45, 45, 90. So I'm going to copy that down from the reference sheet. And now these ones aren't as bad. The 45, 45, 90s aren't as bad. It's usually a lot more obvious because two of the sides are the same. So the hypotenuse is just S root 2, and then the legs are both S. So we're just going to put that on the picture. Hypotenuse is S root 2, and the legs are both S. Now I'm going to circle whatever side I have, so this one. So we know that S root 2 must be equal to 10, and you see what's different about this one. We just have to do a little bit of algebra to get the S by itself. So what we're going to do is we're going to divide both sides by root 2, so we get S equals 10 over root 2. Now to simplify this, we're going to multiply the top and bottom by root 2. That is called rationalizing the denominator. And we get 10 root 2 over 2, or 5 root 2. We can now put 5 root 2 wherever S is on the picture. So let's do that. And so the length of side BC is 5 root 2. And the perimeter, we just add up all the sides. So 5 root 2 plus 5 root 2 plus 10. And that simplifies to 5 root 2 plus 5 root 2 is 10 root 2. So we get 10 plus 10 root 2. So scientific calculators can be a big help for all the radical math that come with these questions. So this one wasn't so bad, but we're going to do harder ones later. 10 divided by root 2, 5 root 2. And 5 root 2 plus 5 root 2 plus 10 is 10 plus 10 root 2. Would have saved you a little bit of time, a little bit of stress. You can also use a Casio calculator. The FX115 and the FX991 can both do this. Those are both great options, especially for international students. I don't want to blur the focus of this video, and I also don't want to make it too long. So please just know that I'm not going to be going over this for the rest of the video. I'll probably just put calculator input on the screen. If you want to know how to divide radicals or simplify them by hand, just look it up on YouTube or Khan Academy. There's a ton of videos on it. All right, so you see another way that they can make these questions trickier is they'll give you the picture, but kind of like the triangle will be like rotated or something, so it'll look different. So I see that this is a 30, 60, 90, so I'm going to put that on the screen here on my scratch paper. And now I'm going to very carefully label which side is which. So look, across from 30 is the X side, so we're going to put an X there. Next, across from 60 is the x√3 side, so we're going to put an x√3 there. And the hypotenuse across from 90 is the 2x side, so we're going to put a 2x there. Now we're going to circle whatever side we have, which is this one. So we write down x√3 equals 7√3. We divide both sides by √3, and we get x equals 7. And we can now start putting x equals 7 into the picture. So that side over there is 7, and then 2x, 2 times 7 is 14. So we can put a 14 there. And now we're going to find the area of this triangle. So remember, the area of any triangle is 1/2 base times height. When you have a right triangle, the base and the height are just the legs. So in other words, the two sides that are not the hypotenuse. It doesn't matter which is which. So I'm going to do 1/2 7√3 times 7. And that should give us 49√3 over 2, which would be our final answer. And once again, guys, there's not that many problems in the worksheet. You really want to make sure that you have this down pat before you do some of the more challenging ones. So I would highly recommend you go to this unit on Khan Academy and just do it over and over until you feel good on it. There's also a great website called Delta Math. Make sure you go to the link that I have and create an account as a teacher. It doesn't matter. You don't actually have to be a teacher. You could just use your Gmail account as a teacher. And then you pretty much have unlimited access to all of their free content. So you see if you type in special right triangles into the search bar, there is a list of procedurally generated questions that you could just do like over and over again until it starts to make sense. You probably want to do the one that says radical answers because that's often how the SAT will treat it. Okay, so now we're going to talk about area and perimeter problems. So we're going to do a 30, 60, 90 first. So as we were talking about before, area is 1/2 base times height. So for this triangle, that would look something like this: 1/2 times x√3 times x. Remember, we used the two legs, just not the hypotenuse. And that will simplify to something like this: area equals √3 over 2 x squared. For perimeter, we add up all the sides. So 2x plus x√3. We can combine the like terms, so we get 3x plus x√3. And now we can actually factor out the x because both those terms have an x. So we get perimeter equals 3 plus √3 times x. Okay, for an isosceles right triangle, the area is 1/2 base times height. So we can do 1/2 times s, which gives us area equals s squared over 2. And for the perimeter, we add up all the sides. So s plus s√2. We combine the like terms and we get 2s plus s√2. And we can we can factor out an s. So the perimeter is equal to 2 plus √2 times s. So you might notice this is the first time I've probably ever on this channel gone over how to derive an equation. And there's a reason for that. It's because these questions are hard. These equations are hard to remember. I don't want you to memorize these. I just went through the derivation because I want you to be able to look at the reference sheet just like this and quickly figure out, like in particular, the perimeter equations in about 30 seconds, and then you can solve the rest of the question very quickly kind of once you do that. It's the kind of thing that is really scary if you've never seen it before, but if you've seen it before, you know, just looking at the picture will hopefully jog your memory and you can start adding them up and factoring. So just kind of make sure, I'm going to just use these equations from now on, just assume we kind of did those first 30 seconds, but I would make sure that you just use the reference sheet to figure these equations out. You don't have to memorize them. Okay, so let's do some problems. So it says an isosceles right triangle has a perimeter of 23 plus 23 root 2. Okay, so we're going to put 45, 45, 90. That's an isosceles right triangle, right? And seems like we're going to need those area and perimeter formulas. So we figured those out kind of off screen as we already did. And it says the perimeter is 23 plus 23 root 2. So I'm going to put the perimeter is 2 plus root 2s. And in for p, we're going to put 23 plus 23 root 2. Now to get s, we're going to divide both sides by 2 plus root 2. So we're going to divide both sides by 2 plus root 2. I'm just going to do that on a calculator. We get s is 23 root 2 over 2. And for the area, we're just going to take that equation and put in the number we just got for s. So also going to do that on a calculator. 23 root 2 over 2 squared divided by 2 should get 529 over 4. So the two answers to this question would be 23 root 2 over 2 and 529 over 4. On the actual test, they'd probably give you some nicer numbers, but I still thought this was a good introductory example. Okay, so for this one, we're going to do a 30, 60, 90. So that's this one, and the equations, you know, jot them, come up with them on the test. You don't have to memorize them, but let's just assume we did that part already. And it says we have an area of 12 root 3. So we're going to put in for area 12 root 3. And now we're going to solve this equation for x. So the first thing I'm going to do is I'm going to divide both sides by root 3 over 2. And we get something like this, x squared equals 24. Now we're going to take the square root of both sides. The square root of 24 simplifies to 2 root 6, so we get x equals 2 root 6. So the shortest side is the side across from the 30. So the x side is the shortest. So that's the answer to the first part, is 2 root 6. I guess inches. And then for the perimeter, we can find all the sides and add them up, or we can just use the equation. So 3 plus root 3 times x. We're just going to put in 2 root 6 for x, and I'm going to do that in a calculator. And I get 6 root 6 plus 6 root 2. Okay, so the final skill of the video is combined shapes. And we would be here all day. We would need a whole nother video to talk about combined shapes. There's a lot of different combined shapes on the SAT. I'm just going to go over what I think are two of the most common combined shapes that involve special right triangles, because that fits the theme of today's video. So the first one that shows up a fair amount is an equilateral triangle. So equilateral triangles, all the sides are equal and all the angles are 60 degrees. So you could imagine if we drop an altitude and cut it in half, it forms two 30, 60, 90 triangles. So you can use a 30, 60, 90 special right triangle to solve problems involving equilateral triangles. So we're going to do that now. So it says an equilateral triangle has a side length of 20 inches. What is the area of the triangle in square inches? So we're going to first draw it, and you could put 20s everywhere, but I'm just going to put it on the side on our left triangle that is important. And we're going to check our reference sheet, copy it down. And now we got to be really careful with 30, 60, 90. So remember, the side across from 60 is x root 3, the side across from 30 is x, and the hypotenuse is 2x. Now we are going to circle the side we have, 2x equals 20. And we divide both sides by 2, and we get x equals 10. And you can now put that on the figure. So 10, and then the other side is 10 root 3. And you probably already could kind of see that the bottom side gets cut into two equal parts. That is true. You could have labeled that right away, but I just showed the work to show that it still works out. And now to find the area, and again, guys, we're trying to find the area of the whole triangle, not the triangle we drew on the left. We want to find the area of the whole triangle, the entire thing. So the base is going to be this entire side. So the base, very common mistake is to say the base is 10. The base is not 10, it's 20. And then the height is the height we drew, 10 root 3. So we're going to do 1/2 20 times 10 root 3, which should give you, half times 20 is 10, 10 times 10 is 100, should give you 100 root 3, and that would be square inches. So just be really careful that you'd hate to do all that work and then get the base wrong at the end. So just make sure you're using the full base. Okay, another very common combined, well, you know, as common as it can be, combined shape that involves special right triangles is a square inscribed in a circle, which looks something like this. So as you can maybe picture, we can also cut squares in half, just like how we would cut, almost like how we would cut an equilateral triangle in half. When you draw a diagonal in a square, it forms two 45, 45, 90s. Now notice the diagonal is also the diameter of the circle, so that is really important to recognize to solve problems. So let's do an example. So it says a square is inscribed in a circle with a radius of 16 inches. What is the perimeter of the square? Okay, so we're going to draw a square inscribed in a circle. And we can draw our 45, 45, 90. And see how it says radius of 16 inches? Remember that diagonal is a diameter, so we have to double it to get the diameter. So we're going to put 32. 16 times 2 is 32. And we're going to, of course, pull up our special right triangle from the reference sheet, copy it down on our scratch paper. And we are now going to label the sides. So the hypotenuse is s root 2, and the legs are both s. And now we're going to circle the side we have. So s root 2 equals 32. We divide both sides by root 2, and we get s equals 16 root 2, and we can put that on the picture. So both those s sides are 16 root 2. Now to find the perimeter, you can label all the sides and add them all up, or you can use the equations for squares. So the area of a square is s squared, and the perimeter of a square is 4s. So that's what we're going to use. Perimeter equals 4s. So 4 times 16 root 2, which is 64 root 2. So that would be 64 root 2 inches is the perimeter. Very good. Okay, it's time for the final review. Remember to download the free final review worksheet using the link in the description. Try to complete the worksheet yourself before watching the rest of the video. Be on the lookout for a pinned comment with more helpful links about today's topic. Okay, let's get started. So, you're going to see this a lot on the DSAT, whether it's on purpose or not, I don't know, but they don't give you the picture, they actually make you draw it yourself. So it's a 30, 60, 90 triangle, so I'm just going to draw it kind of the way it is on the reference sheet. I mean, why not? Why make it more confusing for myself? So 30 degrees, and that's angle A. And it says angle B is a right angle, so I got to put B. It says the length of side AC is 24. And now I'm going to, in a different color, label all of the sides. So across from 30 is x, across from 60 is x root 3, and across from 90 is 2x. Okay, I see right away that 2x equals 24. So let's write that down. Divide both sides by 2 and we get x is 12. So these sides are 12 root 3 and 12. So it says, what is the length of side BC? Well, that is 12. And then the perimeter is 12 plus 24 plus 12 root 3, which should be I think 36 plus 12 root 3. I think that's the only thing we can simplify. Yep, that looks good. And again, you never really have to put units on the SAT, so I'm kind of saving space here, but you should be mindful of it. So the BC is 12 inches. That's good. And then the perimeter is 36 plus 12 root 3 inches. Okay, we got an isosceles right triangle. Okay, so let's kind of again copy that from our reference sheet. So I'm gonna do that. And I'll just draw it exactly as it is in the reference sheet. Why not? And angle B is a right angle. And why don't I put A up here and C up here? And these guys are both 45, so I should probably label that. Remember, guys, we talked about isosceles right triangle is just a fancy vocab word for a 45, 45, 90. Okay, the length of one leg. Leg is one of the shorter sides, so why don't we say this one is 9 root 2? And these guys are S, S, and S root 2. So you can kind of see right away that 9 root 2 is S. So I'm just going to put that everywhere. So 9 root 2 is here. And then 9 root 2 times root 2, which is 9 times 2, because the root 2 becomes a 2. So that is 18. And we want to find the area of the triangle in square inches. So the length of the hypotenuse is 18. And the area is 1/2 base times height. So 1/2 9 root 2 times 9 root 2, which should be, let's see what that is. 1/2 9 root 2, 9 root 2. Should be 81. So the area should be 81 square inches. Okay, looks good. Let's keep going. Okay, we got another isosceles right triangle, so I'm going to once again kind of bring this guy over here. And we have, once again, S, S, S root 2. And then these guys are 45. And the length of the hypotenuse, that's the longest side, is 41 root 2. Hopefully you guys can kind of see by looking at this that you see S is 41. So if S is 41, then we're going to put 41 and 41. And we now want to find the perimeter. So 41 plus 41 plus 41 root 2. That is 82 plus 41 root 2. And that would be in inches. And I should have labeled it. I didn't do it because it doesn't really matter so much because it's all symmetrical, but angle B is a right angle. So I'll label that ABC. Great. Triangle ABC is a right triangle. Okay, so this, I see 30 degrees. Okay, so I'm already kind of thinking this could be a 30, 60, 90. So let's pull that down. Copy that down straight from our reference sheet. And I am now going to draw it. So one of the angles, angle C is 30. So I'm going to put C. Angle B is a right angle. angle A. 90 minus 30 is 60, so this is a 30, 60, 90. And side BC has a length of 57, so let's put that, 57. And let's also label all the sides. So across from 30 is X, across from 60 is X root 3, and across from 90 is 2X. You can kind of see from here that X root 3 equals 57. And how about save ourselves some trouble? We do that on the, I don't know why it keeps doing that. Here, how about I do this? That might be a little bit better. Okay, so we're going to do 57 over root 3. And it seems we get 19 root 3. So X, let's go back over here, is equal to 19 root 3. And we can now label that on the picture. So 19 root 3 would be the X side. And then the 2X side would be 2 times 19, 38 root 3. And now to find the perimeter, I think that's what we want to do for this one, is we're going to add them all up. So 57 plus 19 root 3 plus 38 root 3. So that should be 57 plus, what's 19 plus 38? 57 root 3. And that would be in inches. Great. Okay, let's keep going. Okay, this one we probably want to use the equations for an isosceles triangle that we came up with before. So I'm going to do that. So let's just get those again. On the actual test, guys, you pull up the reference sheet and figure them out. I'm just trying to save time for the review here. So the perimeter of an isosceles right triangle, so we're going to put 98 plus 98 root 2 in for P. So the rest of the equation stays the same. And now we're going to divide both sides by 2 plus root 2. And then this will go away. And let's see here. So we're going to do 98 plus 98 root 2 over 2 plus square root of 2. And it seems we get 49 root 2. So why don't we write that down for S? And remember, guys, S is the length of the leg of a 45, 45, 90. So I think we're done. It's just 49 root 2 inches. Great. That's it. Okay, let's keep going. 30, 60, 90 has a perimeter of 15 plus 15 root 3. Okay, so let's pull up the equations for 30, 60, 90. So that's these ones. And let's see here. We're going to do perimeter. So perimeter 15 plus 15 root 3 equals 3 plus root 3 times x. And you guys kind of see, you could probably tell right away anyway, but let's do the same thing over here just to show how helpful this is. 15 square root 3 over 3 plus the square root of 3. And we get 5 root 3. So we're going to write that down. X is equal to 5 root 3. Let's come back over here. And we're going to find the length of the longer leg. So the legs, let's pull up the picture just for the sake of clarity here. So the legs are x. One of the legs is x, and then the other leg is x root 3. So side lengths in a triangle are proportional to the angles across from them. So the shorter leg is x, and the longer leg is x root 3 because it's across from a bigger angle. So we want x root 3. So the longer leg, the side that we're trying to find is x root 3. So we're going to put in 5 root 3 for x. Root 3 times root 3 just becomes 3. We get 5 times 3, which is 15. So I believe the answer is 15 inches for the length of the longer leg. If they wanted the shorter leg, we would have just said x. The answer is 5 root 3. Great. Let's keep going. Okay, more 30, 60, 90 formulas. Let's pull those down. Okay, so it has an area of 8 root 3. So we're going to put that in for A. Very first thing I'm going to do is divide both sides by root 3 over 2. Let's see what that turns out to be. So 8 root 3. You could also multiply by the reciprocal, multiply by 2 over root 3, whatever is easier for you. And let's see, we get, oh, that works out nicely. We get 16. So let's come back over here. So our equation should look something like this. X squared equals 16. We take the square root of both sides and we get x equals 4. And that's important, but it's not our final answer. And for the perimeter, we're going to do 3 plus root 3 times 4, because x is 4. So the perimeter would be 12 plus 4 root 3, and that would be in inches. So I think that is right. Very good. Okay, let's keep going. Okay, now we have some of the combined shapes. So why don't I copy the figure? Okay, here we go. So we have an altitude of 11 root 3. So let's write that. And then let's also label all the sides. So the across from 60 is x root 3. Across from 30 is x, and across from 90 is 2x. Hopefully you guys can kind of see that x is 11. So we should write that down. 11 root 3 equals x root 3, but you get x equals 11. So now we can put in x equals 11. So this is 11, and this is 22. So it's equilateral, so all the sides are 22. So you can just add those all up, or do perimeter equals 3s, because there's 3 sides. So 3 times 22. And that should give us 66 inches as our answer. So 22 all around on each side. Let me pull up the figure for this one too. Okay, so right away we're going to label the sides. So 45, 45, 90s aren't so bad. It's usually pretty clear. Just the sides that are not the hypotenuse are S, and the hypotenuse is S root 2. They tell us that the perimeter of the square is 24 inches. So if we use perimeter equals 4S, we can see that if we divide both sides by 4, that the side length is 6. So let's just that's important. So we could put that on our figure. So this is 6, 6, and 6 root 2. So you guys are seeing maybe that the diameter, which is this length, is 6 root 2. So the radius is that divided by 2. It's half. So that is 3 root 2. And now to find the area of a circle, we can use the equation pi r squared. So we can do pi times 3 root 2 squared. And 3 root 2 squared is 18. So the area would be 18 pi square inches. The area of the circle. Great. Okay, there's one more. And I think we might need a 30, 60, 90. So let's bring that down. And I'll just kind of put that, how about over here? Okay, so first thing you should realize is that it says line segment TE is tangent to the circle at point T. So for circles, tangent lines are perpendicular to the radius or diameter at that point. So this is a right angle. That's just something you had to know. Now you can kind of see, okay, 90 minus 30 is 60. So this is indeed a 30, 60, 90. And we can once again get everything labeled. So the hypotenuse is 2x, across from 30 is x, and across from 60 is x root 3. And they tell us another bit of important information, that line segment TE is 48 centimeters. So let's put that. This is 48. Okay, so right away I'm going to recognize that x root 3 equals 48. And I'm now going to divide both sides by root 3. You can once again, if you want, just do that on a calculator. Up to you. You should get x is 16 root 3. That's important. I'm going to put a box around it. And we could start putting that on our picture. So this is 16 root 3. And I don't really care about the hypotenuse. That's not really going to help us answer the question. So I'm not going to label it, but I guess it would be 32 root 3. But again, don't worry about it. I'm actually going to just erase this entirely. I don't think it really matters. I'm kind of done with that at that point. Okay, so now we need to find some stuff about the triangle and the circle. So let's just, while we're talking about it, do you guys see that this line right here, CT, that is a radius. So the radius is 16 root 3. So we should probably write that down. So I'm going to write that down off to the side. Radius is 16 root 3. And it's asking about area, so we probably want to find the area of the triangle. So let's do the area of the triangle. Is 1/2 base times height. Doesn't matter what you call which, so just the legs. 48, 16 root 3. So the area of the triangle is 1/2 times 48 times 16. 384. root 3. I bet that's important. And now this is something we didn't talk about this video, but combined shapes are just like this. So it wants us to find the area of the region that is both inside the triangle and outside the circle. So that is this. So we have the whole area of the triangle. So do you guys see if we now go and find whatever the heck this is, we can take it away from the area of the triangle and get our answer. So that little yellow piece is called a sector. So the equation for sector area, SA I sometimes call it, is theta over 360 times pi r squared, which is where theta is the central angle. So we're going to do 60 over 360 times pi, and then the radius we already talked about is 16 root 3. And that's got to be squared. I forgot to square that. Okay, that is probably going to be a pretty big number. I don't really want to do that in my head, so let's see how this goes. Let's try it. Oops, didn't mean to do that. Pi 16 root 3 squared. Okay, we get 1/6. 128 pi. Yeah, that seems reasonable. Okay, so that looks good. So 128 pi. Let's come back over here. So the sector area is 128 pi. So now to find the area of the pink or the shaded region that we care about, we're going to do the area of the shaded is equal to the total or encompassing area minus the area that's unshaded. So we're going to do the total area, which is the triangle, 384 root 3, minus the unshaded area, which we don't want, that is 128 pi. And let's actually see what we get here. I don't know what it is. That would be our final answer because it says to use exact numbers, but on the SAT they would probably just give it to you like multiple choice. So I'll round this to the hundredths. It's 262.98, and that would be square inches. Okay. Very good. Let's go back to the slides. Okay, everybody, that's it. Thank you so much for watching. Please comment below your thoughts on the video and worksheet. Did you find them helpful for your studying? Like the video and subscribe for more digital SAT math content. And if you need tutoring, my website is linked in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying.